start. Let me share my screen also. Sure. Can I tell the older doc? Can please use it? Yeah. Dang, advanced. I want to share all my stuff. Sure. Sure. Okay. So database and NPI. Today we're gonna review like where to get data. I think this is the most important part. And to get data, we're gonna see some ID that are not flat file, but sometimes you get data also in flat file. I have not mentioned it, but now that I think about it, you can get data from Google Drive, Google Spreadsheets or Airtable, which usually used some kind also of API or XML. So we did not discuss them, but they exist. The learning objective, they are very simple. Is understand how and learn how to access a database and the similar from REST API. I keep that slide from the previous talk. I'm gonna make the chat open also if I can. Today I'm on another layer. Where's the chat? Is more chat here. So you have it. So this was from the previous chapter, but I keep it because like I think the idea is like you're gonna use database as a services or data as a services, and this is the idea that connects to the three layers we have seen previously. And when to use what? It starts with something that I disagree, which is database versus data warehouse versus data lake. And like I think a database can be a data warehouse and a database can also be a data lake. So I'm going to define the database later. It's super hard to define the data warehouse and it's also super hard to define a data lake. I'm going to try to define them. Keep in mind, like there is also definition. A data warehouse is usually like a place where you can do analytics. So let's say like you have sales data and the sales data are managed by an operational database that's record every sale. And you, for like the data team to work, usually like the data engineers or like the operation people have moved this data and organize it for a way to do analytics. And this is a data warehouses. So it's a basically like people shortcut that. I think it's a structured data. But a lot of stuff are structured data, like a JSON is a structured data, a table is structured data. So it's more like a space where like the operational data have been moved to be accessible in a structured way that's structured way for analytics. The data lake usually is a place where you store unstructured data. But then what's unstructured data? I mean, like basically it's gonna be a bunch of files, it's gonna be a bunch of stuff. That's usually like by that what data is stored in the data lake is files, and we're gonna discuss that a bit. There's the data lake house, which is the new stuff now, which is a mix between the warehouse and the data lake. It's basically like when you store files, then you get issue on, let's say like you have like, you decide to have your cell for 2000, the last previous years. And you store them into like a gigantic table in the data lake. Let's say a CSV. Or let's say, let's be an optimist, a Parquet file. Then next year's like, what do? Let's say like you have like the new year's. Do you just add a file and let's say like you have like in 2024 you have like the data was incorrect and you need to update it. Do you update the file, changing everything, and then maybe you risk to break something, etc., etc. So a data lake house is kind of a solution to manage this kind of problem where you have multiple versions of the same object. And there's plenty of plugin to the data lake house. It's right now the industry is a mess, but that's basically it. Like the data lake house is a layer on top of the lake that allow you to do stuff that the database do. That's basically handling multiple version of some ID. I don't know if that's clear. Feel free to ask in the chat.
Would pens, in a certain sense, be considered like a data lake by that definition?
I mean,
In the sense that objects are versioned? Or at least it
uh,
has that attribute, I guess.
you use a data. I mean, I like data lake a lot, especially with S3 as a backend, because now you can also plug a database into it. So I'm gonna review that a bit later. But basically, like a data lake has trouble when you start to have update of some objects. What could be a good example? Like, let's say like you have like you are selling some stuff, and you have selling like, I don't know, shampoo, and the shampoo is like from a famous brand, and the brand changed, but the product is still the same. How do you manage like the ID of the shampoo, previous the sale and something like that? It's basically something that have changed inside of the data that you need to update. And it's even worse if you change the structures. Let's say like you organize your database by departments, because like you want people to monitor something in the department, and the department change. Like let's say like the HR become a human, not anymore like human relation, but like talent assets. But it's not just a change. Like maybe some of their job is moved to the, I don't know, the finance people. So when the structures of the data change, the data lake become complicated. So as well, like you go back to using a database and implement some of that, or you use a data lake house, which is basically like trying to organize the connection between your file with some kind of, I mean, it can be a database, but it can also be like some kind of JSON, and this is gonna be like the mess of iceberg and Avro. Is it clear?
Clear. I mean, but also for me, I have very limited exposure to this stuff, so
I
already you're
mean,
helping me get a little
like
clearer on my ideas. Thanks.
basically like a data lake is for like you don't need to update stuff. Like let's say like my example was bad because like you can assume like 2024 cell, they're gonna stay the same. They're not gonna change. But let's say like in 2025, in my shampoo example, the shampoo name changed, or the provider of the shampoo name changed. So all the connection are on the 2024 file are not going to be the same on 25 file. How do you manage that consistently? This is like the question,
Got it.
like when you start to have like this kind of changing dimension, this is the name of the technical term of it. This is start like where you should, maybe the data lake was not the good option. And that's why like people move either for data warehouse or move for data lake house or whatever. Recommended solution. So EBS is elastic block storage. RDS is database storage. Redshift and Redshift. I never know exactly what Redshift is, so I'm not gonna go into it. I think it's some data, probably some database, a mix of everything. It's a data analytic platform, and S3 and object storage. So both of these four are AWS products that are good. But I put before, like, be careful because technology is different than concept solution. So data warehouse is usually a concept. And the technology implemented could be a database, could be like usually a database. But it could be OLAP Cube, which is another way of messing around. And Redshift, that's why I don't know exactly behind Redshift. And S3 and EBS are storage solution. One is a block storage, and the another S3 is an object storage. So I really like. It's not like I'm not using much Red Hat product, so it's not like. But I like this presentation. What is file object storage? What is block? I mean, you probably are familiar with the file storage, which is a hierarchy to organize stuff. Block storage is another way, and object storage is the trendy one right now, which is based, S3 is based on it. Okay, so, and we have plenty of other ways to put to store data. Like there's tremendous stuff, tremendous product. We always invent new term, but the database is rock solid. And what I want to say also It's like even if you use S3, you can now with DuckDB use a database on top of your object storage. And I'm gonna explain that a bit later. Does some of you have question around that?
Yes, so
Yeah.
you have like the concept, as you said, data warehouse, data lake, and then a way to implement it, like at this
Yes.
layer.
And not only you have way to implement it, but you also you have vendor solution,
Okay.
which can be hybrid.
Okay.
For example, Redshift, I should look exactly, but in my mind, it's a mix between a database and an object storage.
Okay.
Yeah. But like I think it's very important like to understand what's part of it is technological, a solution, let's say. And even in a solution, we're gonna see like plenty of way of doing it. Okay. What's important, it's meet the data where it lives. I think this is very important. So I mentioned like sometimes you have flat file, sometimes you have database, sometimes you have web API. And even if you have like, let's say, a data lake, technically, you kind of have an abstraction of flat file. Because like the object storage are gonna represent their blob as an abstracted file. So it's a fake file. It's a fake file system. There's other cases. I didn't wanted to delve into it, but for some people it may important. You have videos, you have sensors that's streaming data, and sometimes you also have user inputs. And there's probably more. I like this example. It came from Martin Klipman. I pronounce the name probably terribly, which is the book Designing Data Intensive Application. And it's a fake example. I use it also in my presentation for this. It's a small shell script that's gonna implement a fake database. We can review. So it's a shell script. I have I have put it here. So you have also hits. I should. Oops, dang, no. Go back, zoom. ls. So I should. So it's still basically some function. One is setting something, setting a line, and the other one is grabbing a file, setting a line in a file, and the other one is like grabbing by the first element of it and return just one element. Let's do it. So sudo shares mode. I never know. I think it's plus X. And the name is dummy. Okay. So now it's accessible. So I'm gonna source it. I don't need necessarily to have accessible. Oops, sorry, one. Okay, so now I have access to that function. db set Bill 42. I always do that. And if I do db get, Bill, I should get 42. It's bad. See, I failed a bit here. Anyway, and if I do db set Bob, I don't know, 32. And if I go db get Bill, I still get and if you get Bob, and just to show you, like, let's say Bill and no, like 67. If I do db get Bill, I just get the last one. Why did I get the last one? It's because
You're muted, Oliver.
No, you're muted.
I press M, sorry.
Mm-hmm.
See, I have one comma somewhere like in my implementation. I think this is probably, I think I don't need to pass the comma when I typing it. Anyway, so, and that's it. So here, the term database do a lot of work because it's just a file, but it's important that a database is also like just a file somewhere, and technically a bunch of them, that you're gonna access it. Now, why this implementation? Why this implementation is bad? There's plenty of stuff that's wrong with that. Okay, I'm gonna give you one. What happens if I want to have, like, let's say Bob, the first variable that I type was a name, the second was age. Let's say next, if I want the profession, what do? I need to go back to my implementation. This is my implementation, my simple bash script, and add
Update.
a new stuff here. And I need to add it also to my setting function and to my getting function. And every time I do something from the structure of my data, I need to change my structure of data. I need to change my application. No, like, and I also like highly dependent on this file, like this database file, which basically means like I rely on my file system to get to it, to get it. And the database file should be like right next to right next to my application, like the path is hard coded, everything is wrong. And yeah, so the most problem is like my application, it's tied to my storage. Both are very close tied. A change in the structure of the data need to change the application and vice versa. And the other problem is like I'm tied to the operating system. And right now, I have my operating system. So, any question? And there's plenty of other stuff wrong. There's just more like there's the two big stuff that are wrong. Like obviously, I'm choosing to return just the last one. I should return all of them. This is just based on the grep. What happens if like there is typo? Like there is no structure enforced in my setting function. Like we should also like say, look, the first should always be a characters. It's not, so you should have types. Plenty of stuff is wrong here. It's a very good, but it's still a very good example and a very good simple example of basically what's the database. This database is storing data somewhere and getting it. Okay. Yes, and no, like this is so basically what database does is that it isolates the data from the operating system because it implements its own way to get the data from the operating system, and it isolates itself also from the user application. And you, let's say, like, when you use R to connect to a database, you are on user application, and you don't need to write specific codes. I mean, the code you write are not going to change what's inside of the database unless you want to update what's inside of the database. The core concept is like you have relation, that's a fancy name to call table, as data structures. And when you fix that, like every stuff is going to be stored as a relation, it's fixed a lot of stuff. And then the database is the one that's going to manage the storage. It's one that provides you a declarative language to access it. That's usually SQL. And your application are happy because then you have multiple applications. So the physical schema, let's say, the database storage in an example like could be an S3. The physical schema to accept it will be like a file system or a fake file system. And the logical schema is how will we define like your name, your age, and let's say like your profession. This is going to be like the name is going to be a string, the age is going to be an integers, and the profession is going to be a string. And then your application know that and can access the data. So database is all of that. But that's like the core idea is like, if I want to change some component, I can. It's also modular. Let's say like no my logical schema, age, I mean name, age, and profession could also work on the DBs. Could also work with a file system. I could implement it completely differently and change my physical schema in my database storage. And also like that's the core idea. Any question around that? Because I think this is like a database is not just something like in the chapter. It's like the database is just like just something like you get with SQL. I mean, by the way, I say SQL. It's fine if you say SQL or that's. I don't think there is any rules. Yeah, you have question? No. Okay. Okay, accessing and using database. Basically, like the core concept is like to access the database, you need to have drivers that are compatible with the database. And either in R or Python, you have two different kind of way of doing it. Here, like PsychoPG is the package that connect to a lot of database. It has a lot of drivers implemented. So if you connect to a PostgreSQL database, PsychoPG2, and the connect method on it, it's a method. It's gonna connect you to the data. I mean, here, like you will have the argument here. Like probably a bunch. We're gonna use them later. And this is like the exactly similar, like you're gonna import a package for DuckDBs. And here you specify like my DuckDBs is something that's live on data, which is a file, which go back to here, like, see, I have a logical schema and I don't care. The physical schema right now is the file, but it could be something in memory with DuckDB. In R, it's a bit different. You have a DBI package that's provide some kind of generic methods for all of the drivers, and then you specify the drivers, which is different from Python, where like you have one module that's usually specific to one drivers or multiple drivers, depends. So the most common drivers are ODBC, GDBC, I pronounce probably, or JDBC, I pronounce probably that incorrectly, or it's the open one. JDBC is the one based on Java, and now you have another one that the book does not mention. It's ADBC, which is A stands for arrow, and there's a DBC stands for database connectors. So if you run to the database, like you have the database as a query engine, which here in my stupid example, my database engine was my shell script and my two function. But usually like the database will provide like a more stable API. That's the crappy shoot that I'm not writing, but that's writing here. It's bad, but it does the job. Okay. Question around that? We good. Credential are a pain. They are like my nemesis. You can manage it plenty of way. And usually you will manage plenty of way. Like now you have commercial solution that's require you like usually to have a phone to two-factor notification. So I mentioned Bitwarden and 1Password. I use Bitwarden personally in my previous job. We use 1Password. This is probably more. You can use your OS keyring. I don't know if I have one here. I think I have it. I have one, I'm pretty sure. Oh, no. Oh, it's Python keyring, I guess. But I think I have the keyring installed, so somewhere you have one. You have GitHub secrets and plenty. Like this list is not exhaustive. The basic idea is like the creators usually have all the rights, the user have less rights, and the viewer have less rights. So it's follow like this kind of hierarchy. And you can also like divide them by group. You can also have them by file, have them by on the database, you can have them by you can then set up by group, by users, but also by schema. Like there's like plenty of work managing credential as a like, but usually like the data scientists, they're gonna be provided credential of what they have, and they're gonna use that credential. But like the credential setup, like the write, the read, and others, like you can also like set up like the credential like have timestamp. They can be only like for a specific time, etc., etc. API, that's another way. So, but the credential, they are for the database. So what's important is usually the database is going to implement that credential for you. And the credentials are going to be stored somewhere, and everyone have opinion on that. API. Good difference is like they can be private. The most private one is the one you own on localhost. That's your random machine. You can generate a web servers, and the web servers as an API basically. Or they can be public, and even if they are private, not on your machine, they can require notification, so you can access the information. Python use request, and R use ethers and iter2s. I learned recently that this is how you pronounce it. So this is why the logo is like a baseball guy. So I always say HTTR and HTTR2, but the cool people said haters. And the author mentioned there are both syntaxes triggers. I'm not clear around what. My guess is curl or CURL or just the HTTP protocol. Yuma, do you know on what they are wrapping?
I think it's curl actually. Because I know for HTTR, there are lots of curl options that they expose that, and I think there's this whole document that gives you like a mapping between like the raw curl names and then what header provides.
Technically, curl is also a wrapper on a bunch of protocol. I mean, it's implement the protocol in C, but I don't know. I mean, I will have like more information here, but that's fine. We mostly have seen like in this chapter, we mostly see like the REST API. I never remember like it's represents something stateful. The acronym, the whole idea is like it's a way of organizing architectures around the web, architecting of information, and it should be like not depending on the state. So basically, every time you send a request, the application does not care, like you have said 10 times the previous request. Or you can click on it and read the whole stuff. And I really enjoy your presentation. So if you have time, you can go and look at it. It's very well done. I mean, the first part of it is more about what we see, and then let us go a bit deeper on other stuff. It defines everything better than the book. Yeah, you have like the same diagram that I provide you, and a good example. So I'm going to use some of his example letters, and we're going to go back to it. And Yumer, if you want to talk, like feel free to do it. It's based on the HTTP, so it's a protocol. It's a protocol forward for client-server interaction. And basically, like the API is a middleman between the servers and the clients. I did not decide to put S as servers and clients. Usually you have multiple clients and you can have multiple servers, but I think like there are more abstraction. API is a path, and it starts by the roots after like the localization. And it have multiple endpoints. The example that the author is giving, the ping example from like Vetiverse. And then because it's implement the HTTP protocol, you can use the verb. I think I agree with the author. I mostly use get and post. Get is for getting data. Post is basically for getting data, but providing information. So the server is processing it and send you back something. You may want to add something on that. I'm looking in the chat, probably good. Oh, someone said like, yeah, and 0. Yeah, okay, perfect. Okay. Here, what's important, and I think this is very clear on one of Humor slide. This is also from his slide. Like basically, like when you define endpoints, you have also define what kind of parameters and what kind of body are going to be returned. Parameters are like information. Basically, like you might use the analogy of a function. I'm going to use it also. Like an API is kind of a function when you provide an argument and it returns something. And the something will be like all the time a JSON object with a bunch of information, because like you're gonna return like the JSON with how did you get that information. Basically, you return not only the object but how you get the object. But the parameters and the body are defined at the endpoint level. So if you have multiple endpoints, they can have different parameters, etc. I like this example. I'm curious if I use it, if I will get 10. Probably. See, I get a JSON object. I can even inspect it. So this is specific of the browsers, but like I assume like Safari and Chrome are gonna return something. So it's returned a JSON object. It tells me like the operation I have done, which is the apps. I guess the endpoints. I mean, let's first go slowly. So it's an API. It's the version 2 of this API. The endpoint is absolute, which is return the absolute, and I provide just one parameter, which is -10. And what it's returned is like what operation I have done, what the operation I provided. I imagine can do more complicated operation, and the result was 10. And here, like you have like the fancy way of doing it, and you can also check the headers, which is like gonna provide a bunch of information from like my origin, what my browsers, I guess, what's my token. Not here, apparently. Oh, where is it? Oh, here, the user agents, and a bunch of other stuff. Someone's saying something on the chat. No, I missed something. And then this is the body of the response. This is basically this one. And this JSON is just a pretty version of it. Let's go back to, so this is you. Let's go back to the slide. And also, usually you need to use a way to prove your access. Here I copy paste one of the example of humor. Here you have like the Cloudflare account ID, which is like basically like an environmental variable that's took from somewhere. And it's a request into MetaLlama somewhere. The request status code. This is my way of reading it. 200 something, you're good. So basically, like you have method from like request or heters. So it's gonna check if you return a 200, and if you return a 200, you're good to check what's inside. And if you don't, either like you're gonna say, hey, can you retry it? That's what I do usually. I do like a while. That's kind of bad. And or for loop, but I retry until I'm bored. But like if you get a 400 something, it's basically your fault. There's a problem in your request, and the link the URL you provide are bad. Curl option that lets you yeah. Yes. And I didn't know that I speak at. I should look at and when it's 500, it's time server fault. Usually like, and there's two options on that. You are the one providing the servers, then it's become my fault again. And and if I'm not the one providing the server, that it's become my fault. It's not anymore my fault. So server faults outside. So I should have like, yeah, the 500 are server faults outside of my scope until like I'm the one providing the servers. That it's become my fault again. Okay. Environmental variable. Usually in ours, this is what they're stored in the dot file. Do I have some here? I don't think my environment have too much secrets. Let's see. Oh, it has. So this is like basically like you can store your secret. I'm kind of curious what I have put here because I don't know if I access. Anyway, So you have like, you can store your secret as environment into like your R environment, and you can also store in the provide file. I mostly use in R environments because I never know. I think our environment are loaded all the time in your session, while our profile are not loaded all the time. I will need to learn which file are loaded. So when R is loaded, it's gonna load the information here. And the information here can be like defining environmental variable, defining some function, or doing some other stuff. So one way is like, for example, loading like your credential here as an environmental variable. Personally, is a environment when I do not care. I use OS keyring, so that's kind of weird, like, but I use it through R. So we can also see it if I go here. And I was trying to make an example before, but I didn't have time. So if I use Radian, I load the library. Keyring, and keyring is at the beginning was a Python library. And if you do keyring list, so apply none function, why? I just tested previously, it works. Is it the correct one? Well, let's see. Keyring support, let's be stupid. False, why not? Well, I don't know. I have previously done it and it worked, and I have like my keyring stored here usually. But basically, like instead of having like using sysgetenv, I think it's Magisto. Sys, I don't know. Sysgetenv something. CO, it return everything. My users, a bunch of other stuff, and it's gonna store also. I don't go to above because there's the mother credential. See, I have a keyring here, so I don't know why it does not get it. Anyway, so you can also Python use OS, which is a module to get environment from your environment shell. And there's plenty of token-based authorization scheme. So how do they work is basically like you're gonna request a third party to get you the credential. You not even know what's the credential here, and you're gonna provide that credential to the app that consumes it, which is the best way of doing it. Like if you have, for example, AWS VPN, you're gonna send a request to their token-based authorization. They're gonna send you like their credential, and that's the credential you're gonna provide. So you have a middleman. Instead of just providing the file that's reading it, you go to, usually like it could be web-based, it could be like you get something from somewhere, a directory that have like, that's no like, hey, Olivier is this guy. I'm gonna provide him a token for this. He has right to that. I'm gonna provide him a token, and that's the token that he's gonna provide. I don't know our implementation of that.
I have one question about keyring,
Yeah.
if you don't mind, or maybe a couple questions. So with the keyring package in R, just if you happen to know, does the environment vary? Well, I guess do your secrets are they only present as environment variables, so they're never kind of
No,
available in memory? So does it work in the same way like our environment works in a certain sense? It's just it
like
has this
if you
additional
ask
step
the
of
memory
fetching
for
it from
like,
the OS.
yes, they're gonna be present, I think,
Okay.
because you load them as an object. I don't know if they are encrypted. They should be.
Okay. I think they're encrypted
Uh,
at rest. I don't know. Yeah. The other thing is I was curious. I see you're rocking Linux, Ubuntu, but Do you happen to know if this works well in Windows and environment corporate settings?
Yes, yes,
Okay.
that's workable. I mean, I don't want to be stupid, but I think is it direct directory? What's the name of it? I never remember the name of it. Directory something. Active Directory.
Windows Credential Store from the Keyring docs.
Yeah,
if
you have
that's
also
right.
Active
Yeah.
Directory. They have plenty of solutions, and I think they work correctly. Let's see.
Very cool. And I guess with the key rings, they're like named stores of like environment variables. Is that kind of broadly how
No,
it works?
kind of surprised that's let's do something completely stupid like kill a terminal and try again. Oh, because maybe I'm locked here. Why my bash? Let's open a new one. Right. Why is it not working? Because carrying list. Oh, carrying list. You need to specify, like you can have multiple. Well, I have something wrong that I should check, but it worked previously. Maybe I still have it somewhere. No.
Maybe if the slides have RENV, then that's blocking, perhaps.
Oh, you're correct, but I don't have it here. You know, like if I go right in here, this is my default shell, no? That's a very good point. Is it because I'm like what was the function ask carrying? Let's me the slides, but no, I'm not sourcing anything.
I can kind of
No.
investigate on my side, Olivier, and kind of get back to the group if
But
others are
just like
interested too.
because I tested, I created like so carrying like allow you to have multiple. So I have just before today I just have one my logging, and you can have multiple carryings. You know, like multiple, and I just created one. The documentation is kind of bad. I mean, it's bad. It's good, but like it will benefit to have like a workflow example. So you need to go through all the reference. Like you need to create a carrying first. Be sure like you have support. I don't know why I don't have. And you need to create a key, and then you're gonna when you create a carrying, you're gonna add like when you create a key, you create a key by carrying, etc., etc., and you can specify the password, etc., etc. Which basically, at the end of the day, what it changed is like here. Let's say like so. This is the package, and I want to speak about this function a bit. So in this line, you are getting the DB users, which will be stored in my DB environments. And inside of sysget.env, you're going to have carrying the carrying get, which is the kget, I guess. No, it's k set. No, kget. It should be a get. Get row get. So you specify this. So you need to specify what's your, because you can have multiple username. Let's say like you are a sysadmin, like you are administrating a database. You have a username as a database administrator, and you can also have a database as users with different roles applied to it. And you can specify like, so you can have multiple username, you can have multiple carrying, and the service can say like AWS something. And that's replaced like, and then you get that, but like when you do the kget, you create that object in memory somewhere. So if you print kget, it's gonna print your key. Okay. This is not what so this function is great. I have no trouble with it. Basically, like, depending, you can also move, because you can move a part of what's an argument of the function inside of the function. So what you are assuming here, like, and let's say, like, first, I mean, there's like multiple ways of implementing it. Because here, like, instead of having user, you can directly put that here. Like, that's basically mean, like, do you have multiple database that you want to connect? And the default assume like this is DB user, but you can have multiple DB users. Then it makes sense to have it as an argument. The same with your passwords. You can also prompt the user to type their password, which is awful. I do not recommend that. And the drivers usually going to be the same. So the drivers is probably fine to put it here. What I don't like too much with that function is what that function does if I use it on it. For example, if I go back to where is it here? What does this line 2 does?
It will just connect you to the database, like using the DocDB connector.
It creates a connection object that allows you to connect to the database.
Yes.
And then you need to disconnect it. So I have a blog post on that. So I'm gonna you're gonna suffer my blog post. So usually what I have seen from analysts is like, let's say, like, this is gonna look like that. So this is the DB getCon, like get DBCon. I'm creating a connection object. Then to read my table, I need to pass that connection object. The connection object is the first argument in the function DB read table. I'm gonna do stuff. Same connection. You need to keep in mind what's the con. This is what sorry. This was bad because like I should have remain, because this is different connection technically. This is also different connection. The name is con, but like it's basically like this one is gonna kill my connection. I mean, not kill, create a connection. Then I'm gonna create a connection without clearing the first one, etc., etc. I have seen like, so the way that I think it's better, and you do some stuff. Let's say you write. So DB write table, it not return an object. I mean, you can write it as an object, but if you do, like, it's return invisible information. The function, like, it's DB write is a side effect. It's produce something somewhere outside of R. And then you disconnect. What I think it's better to do is writing a get table function. It's a function factory. You don't care too much. What's important is like, you're gonna create a new function, get table, that's take a project, because like, I mean, this is taking like a schema, because Postgres is organized by schema. It take a schema and a function and it gets it. And what's important here is this line. So, and I mean, there's two stuff important here. Like, the important is like the get table is inside a function. So if my R session crash, I'm gonna exiting it correctly, and I'm not gonna expose all of that to my global environment. So all of that it's enclosed inside of a function. And that includes also like all my yeah. So, and when that function, when you exit the function, it automatically closes the connection. And creating connection is very cheap. This is no like, it does not cost you like anything. And the same for the right table. The right is always a bit more complicated. This is why I have an ellipsis here. But because like what happens if the table exists? What happens if there's plenty of other questions? Getting a table is easy, writing is always more complicated. So yes, that's my point is like I mean, if you see yourself in that workflow, you should at one time write a function that's gonna get data. And the best way to write that function is writing a function factory, because like you're gonna write plenty of function like that in your life. And that's similar with object storage. That's similar with if you want to write a function. So doing the connection is the first part. It's important, but why not? I mean, you're gonna write this line, and this line a lot. Trust me. And at one time, you just want a function that's gonna get a table. But the counterpoint of that, but I have seen plenty of analysts never do it. So at first, I was doing that because like when you have a connection object, what you can pass is a SQL query. Like you don't like the DB write table here. Like it's a wrapper around plenty of other subfunctions that's going to open a commit, that's going to get the data, that's going to close the commits, and they're going to do plenty of stuff inside of the table. But usually you can pass it, not the DB get, maybe the DB read table. You can also pass a SQL query. You don't need to pass a table name. You can also pass a query. So you can do a select few column where a statement. So with a connection and a read tables or DB execute, you can do plenty of other more complicated stuff. But usually from what I have seen, people just want a table in memory from R where they are more confident. So the caveat of my get table function is like sometimes you want to not hold the table, and you want, inside of having a table, you want to pass a SQL query. That's it. So do you have, and I think this is all I have from like this slide.
Sorry, Oliver. So because with that function, you will get the entire table. It just okay.
Yeah, DB. So we should look at it. I always need to look at it. DBIR. Reference. DB. So read table, you will see. So it implements like depending on the method provided by the package, it's not going to be the same. So it's a DB get query. We select equal form from the name. But like, and DB get query is also a wrapper on sub-level function like DB fetch, DB clear result, and etc. etc. But yeah, it's good to have the whole workflow in mind. But at the end of the day, that's it. So do you have question, remark?
I have one question taking us back, I guess, to the API part. So I've worked a little bit with like both REST and GraphQL APIs. One thing that's really nice about GraphQL is kind of this ability to have introspection, so you can kind of like query and get the schema of the API. Do you know if there's any way to do that with REST, or because I mean, to my knowledge, just go look at the docs and do that. My underlying like concern around this is sort of if I'm writing a package that wraps an API, how to know that the API is changed and not been versioned, and fail like gracefully, if I could put it that way. So if the API schema has changed or an endpoint has been deprecated or something like that, how I as like a package author can know and then maybe also like informatively error for users of my package. I don't know if that makes any sense, but
Yeah, that makes sense. I can tell you how I do that, but I don't know if it's the best answer. So if the structures of the data you change, you should use V1, V2, V3. So you should expose multiple API depending of the structure. Let's say like when the data change and the structure is different, you should have version API. This is one part of the answers.
unfortunately, that's the part I don't control.
The other way you can do that, I mean, normally the documentation, like let's say you consume an API, they should provide a documentation of the parameters by endpoints that you can provide and the example of the answers you can get. Like usually like, and when you build one with, what's the name of it? Like Plumber or Plumber 2, it's well made. So when you generate the fake API, it's going to generate the documentation with the method, with the example, etc., etc. It's going to read the oxygen, so it's produced like the correct documentation. It's well made. So that's one point. So points versioning, points. If you make it, normally it's documented, and if you consume it, normally it's documented. If an API, if you are using an API that's undocumented, it's going to break at one point. That's a red flag that is going to break at one point. Third, if you wrap a package around one, what I tend to use is like I use helper function that's going to provide, let's say like a inside of R, the list of the method. I mean, people tend also to use like R6 object. So what you do with an API is like you basically expect something and you can define inside of the R6 what you expect. So that's another way of doing it. You know, like using an object-oriented framework. So programming, so like your API is modelized, your API code is modelized inside of the object you are working on. I don't know if that makes sense. And then I like providing quick and easy function that say like, you know, like similar to the one that I failed to use as caring support. So you should have similar function that's very simple, like check stuff and do something like that. Finally, what I tend to do as a data engineers, and what I like doing now, especially from API from the government, I download all the data, I structure it my way, I put that into an S3, and then I use DuckDB to get access for it without getting like, because usually like API from the government data does not be, it's updated every 6 months or every years. So downloading everything, put that into an S3 object, and then having it stable, you know, not because like, for example, I worked a lot with FCC data and they did sneaky updates. So they updated the structures of the data that break everything in my pipelines without telling it. So I downloaded everything inside of using the API and I build my own API on top of it where I control it. That's another way of doing it. Getting everything and building on top of S3. And to finish, DuckDB, but a lot of SQL database will have the describe verb. So if you use describe on a table or on a database, mostly on a table, it's going to describe what's inside of it. Describe DuckDB, for example, because the documentation is good. Describe. Will it find it? Yeah. So it's not on the API. I'm moving the question a bit, but so see, you can create. But it's very stupid. You create the tables that have an integer, a key, and then when you type describe, it just describe information. But you can also describe a query. You can describe is a very powerful verb. Here, even like on remote table should work.
Cool, that's helpful. And listening to it, I kind of had the idea of maybe Like one thing might be to kind of just do some I don't know, like smoke tests on the inputs. So like well, maybe there are a couple things, but you know, if I check that the return object is the same form that I expect it to be from an API, and if it's
Okay.
not, you know,
For a lot of questions
I'll
around
let the user
API,
know.
expert here. And like I think the presentation of yeah, I like this one. No, I like one more letters. Where is it? Here. Usually like checking the status code and checking a bit more what's inside of the headers is very helpful before going farther away. But
Good
then
point.
after you trap, you have a crappy JSON object that you need to parse. And yeah. Yumer, do you want to add anything with how to handle changing API?
I think he
I
left.
think I think he dropped earlier.
Oh, dang. Well, ask him on the chat is like definitely a huge expert on that, way more than I. So, but yeah. Other question? I'm not sure we get. Well, see you next week. Next week is Logan. Logan, I hope you can do it. If not, I will prepare. And see you next week.
Bye. Thank you.
Thanks so much. Bye bye.
Thank you so much, Oliver. Bye bye.